two segments that are congruent with one another. Ladies and gentlemen, when you have two segments that are congruent to each other as your given statement, what should you write down first?
Given.
Your given. Dun, dun. So AB is congruent to BC. So we write that down. What should you do to your diagram? Mark it. Please, get in the habit of marking all of your diagrams, guys. The better you get at marking your diagrams visually, the easier this stuff is going to become. Now look at what they changed, and remember what we talked about yesterday. Yesterday we talked about everything that you deal with in terms of algebra, segment addition, angle addition, all that kind of fun stuff, is always dealt with in terms of equality, not within congruency. There's no such thing as additive property of congruency. There's add prop equal, things like that. We don't throw it in there with congruency. So that's why they make that switch from congruent to equal. On your square yesterday, in one of your progression squares, we filled out when to switch between. Well, this is the example. It switches from congruent to equal. The reason is definition congruent. Now, you don't need to write that out. I saw a lot of people writing out the words for that. There's no reason. Make it simple. That's what they're there for. Okay? Now, you may not have any idea what to do next, but if you look at what they did, what did they write out? They wrote out small segment plus small segment equals bigger segment. What does that mean?
Segment addition.
There you go. You don't have to write anything else besides that. It's just segment addition. I don't care if you write postulate or not, doesn't matter to me. As long as you say segment addition, I'm happy. What changed between 3 and 4?
It was AB plus AB, so it's BC.
Exactly. What they did here is they replaced the BC with an AB. Well, how were they able to do that?
Because they're
Because of substitution. Okay. Remember, guys, if you really don't know what comes next in a proof, when you're filling in the blanks, a lot of times it's probably substitution. It's a very, very common step. Okay. We did this definition yesterday. Very good. Anytime you have addition, repeated addition being rewritten as 2 times something or 3 times something or whatever, all that is just the pure definition of multiplication. Because multiplication is repeated addition. And this last step is on our reason bank, and I want to show you guys what it means. We did not go through this one yesterday. It is the symmetric property. And we actually have worked with the symmetric property before. Oops. We actually worked the symmetric property before, you just didn't realize that you did. Let me show you what I'm talking about. Eventually. When you have a segment, if I call that segment XY, how did we label that? Bless you. Bless you. How do we write that out from the segment XY? We just write down XY. And what's another way of writing that segment? That's symmetric property. YX and XY are the same thing because it's the same segment going forward and backwards. It means the same thing when you deal with it in terms of algebra. X equals 2 is the same thing as 2 equals X. One of the reasons that, yes sir? Means the same thing when you start thinking about when you did inequalities. Is 3 less than 5?
Yes.
Is 5 greater than 3?
Yes.
Means the same thing going both directions. Symmetric. Okay? You see that from time to time with the algebra style ones. You don't really see it a lot with a lot of the other ones, but the reason behind this one working, back to it, is the symmetric property. Whenever you see something flip-flopped over an equal sign, it's just symmetric. It just means it's reading it backwards. That's all. Okay? So that one shouldn't have been so bad. It was a lot like the midpoint one that we did, where you had the substitution step where they made it equal to the same segment. It's the same thing. I'm not gonna lie, guys. These proofs are all gonna be the same. Really, maybe one little step here or there different. But if you keep your notes out when you're doing these things, if you look back at other proofs and stuff, they don't change. I mean, they really, really don't change up all that much. And what was the last one? The third one? Third page? One part of this one, oh, I'm sorry, I'm thinking of a different one. Never mind. There we go. It's very slow today. Another suggestion that I've been giving people for doing these, cover up what you're doing before you get to it. Try not to look at everything at once. Look at the subtle differences between the steps. A lot of times that will help by just blocking things out. So you are given angle ABC is congruent to angle DEF. So in my diagram, what I'm going to do right away is make my 2 tick marks. I know those two are congruent. Why? Because it says so. I also know that 2 smaller parts of those angles are congruent, 2 and 4. Those 2 and that one. I'm marking. Right? Now, in the proof then, the actual 2-column proof, what's the first thing that you do? Give it. Give it. Now, what's the next one? Complementary? Definition complementary.
No,
I have the little angle symbol.
An angle symbol.
I don't know.
It's definite. No, it's
Most
only,
I don't understand it.
no. You do. You look what changed. What changed? Congruent, congruent, equal, equal. What changed? It went from congruent to equal. So what do we use when we change from congruent to equal? What do we say? Definition, congruent. That's it. You have that on your square, right? Did you have your squares out? Make sure you have your squares out, guys. You can reference back and forth all the time to these things. Anytime you see a switch, plus another dead giveaway you're going to have this switch is because if you look at the rest of it, it has math. If you start in congruency, you cannot do math. You have to have equality in order to do math. That's why we have that. So now, step 3. What was it? Angle addition. Okay. It's angle addition. Notice. Come on, guys. Notice you have 2 smaller angles adding up to equal the bigger angle. It says 1 plus 2 is ABC. 3 plus 4 is DEF.
That's hard to
What's that?
That's hard to figure out.
Well, remember, you have it on a square, right? What angle addition is and what's... So you have 2 angles adding together to get a bigger angle. So it's a matter of just reading what they're giving you.
Wait, isn't the angle addition at 90 degrees?
No. No. That's the complementary. Okay? And you have to be careful with that. If you're giving complementary, that means angle plus angle equals 90. Angle addition just says angle plus angle equals bigger angle. That's all that is. No. That's all that means. Okay? So this is just like segments. Angle proofs and segment proofs are the same. They just have different symbols. That's it. They do the same math, same setups. Here's your angle addition. All of a sudden, 2 angles are equal to each other. What do you think the reason is going to be? Substitution. The reason that it becomes substitution, going back and looking at where we were at, you have ABC is equal to DEF. Well, ABC is equal to that chunk. DEF is equal to that chunk. Which means when 2 things are equal, to other things, the other things are equal. That's why you can say this and this are the same because of dun dun dun.
Substitution.
Okay? What changed between those two steps?
I mean, there's.
The 4 became a 2, didn't it?
Yeah.
Why could the 4 become a 2?
Because.
Not subtraction,
Division.
because substitution. Oops. Because up here, it says that angle 4 equals angle 2. So anywhere I see an angle 4, I can replace it with angle 2. And like we said yesterday, you can have multiple steps being the same. Happens all the time. And then last 2 should be easy. What happened there?
So T.
Good. Subtraction property equality because the 2's dropped out. They subtracted the same thing from both sides and an equal sign. When you subtract the same thing from both sides and an equal sign, that is your sub T prop equal. Very good. And then lastly, it flipped back to congruency by definition. Okay. Now, to be honest, when you start looking at the proofs that we're working with, guys, they're all going to be kind of the same flow. You start with something you're given, you probably switch it to equality, you're probably going to have to use segment addition or angle addition, and then from there you're going to have a bunch of different substitutions. There's really not much differences within them. Okay? Now look at, I think it's the one above it I want to go through. Yeah, let's look at the one on the very top of that same page. Let's walk through that one. This one's a little bit different in the fact that we wind up with, thank you, sir. We wind up with the reasons given to us. We got to figure out the statements. So let's look at the top one. Again, as you start this stuff through, what you want to work with, guys, is that you want to start by writing down the givens and marking diagrams. The more you write down givens, the more you, where's your worksheet? Huh? I can't hear you when you mumble. I passed them out yesterday. You were here yesterday. Oh, that sucks because your homework's not here. You always start with your givens. Yes, ma'am. Oh. Well, you are just the nicest person that I know. You should be really nice to her for being sitting next to
I
you.
am really nice.
Merry Christmas.
I told her I was upset.
Oh, crap. I was going to do that today. The short period wanted to get this done. Yes, sir. Yes, sir. I just don't call it pos. I just don't put the word postulate in there because it's why pos. It's not a big deal. So obviously we start with our giving. Please. Guys, I know we don't have that much time, and I want to go through this example so I can give you a couple more to do. Okay? Because after tomorrow, you're going to be having to do these things completely on your own. No more fill in the blanks. It's the idea that all of these are pretty much the same thing. Yes, sir? Sure, why not? Once I write down a given statement, I have a diagram. I need to mark the diagram because by doing that, it's going to help me figure out what to do later. It's telling me that this piece, the WY, is the same as XZ. Looking at just the diagram then, just thinking before we get into this proof, is WY, or let me rephrase that, does WY and XZ have something in common? What do they have in common?
I mean,
Length.
Right, but what chunk do they have in common?
oh,
They have XY, very good. Notice in the middle here, they have the same chunk together. So if you have two segments that are automatically the same, I have two segments that are automatically the same,
Yeah.
and if I put them where they have that exact same amount of overlap, shouldn't the overlaps then be the same? Because what do you have to do to the overlap? How would I show it these are the same? I wouldn't add them, I would. So you have overlap, and you're just going to wind up subtracting it out. So when you start the problem, notice they started the problem as congruent. To do math, what do you have to have it as? So why do they write definition congruent here? What did they switch the sign to? WY equals XZ. Okay? Now, this third part here, I kind of wish they would have done 3A and 3B, because you're using the same reason for two parts. Segment addition. Are WY and XZ larger segments or made up of smaller segments?
Made up of small.
They're made up of smaller segments, so let's write down what two smaller segments make up them. So WY is made up of,
WX Y.
and what is XZ made up of?
X, Y, and YZ.
Isn't that just segment addition? Bigger segments made up of two smaller. Okay. Now, why, or what am I going to substitute in to cancel each other out?
You could substitute,
Look at what we have written down. We have WY is equal to XZ.
Yeah.
WY is that. XZ is the other part. So what do we know about those two smaller chunks?
They equal each other.
They equal each other. And now, lo and behold, what do you have that's the same on both sides of the equal sign? XY. So they're going to say subtract the XY from both sides. Should say subtract prop equal. And if I subtract XY from both sides, what are you left with?
WX equals Y.
And then last but not least, is he flip the sign again? Guys, these are this. If you look at this one, look at the one before it and the one before that. More often than not, since really the only thing you know how to do is segment addition and angle addition, is that you're going to be rewriting angles or segments into more than one piece and substituting and setting them equal to each other. Okay, that's how these style proofs are going to work out for the starting points for us. What we're going to do for tomorrow is on this third page, you have the one in the middle, the one that we're on right now.
Oh, I thought it was.
Bit, the one in the middle. Okay, I want you to do that one, and then I want you to do the top one on the fourth page, the last page. So you need to do the one in the middle on page 3. So page 3 middle, and page 4 top. Tomorrow, what we're going to do, we have 2 progressions to look at. And then I also want to go through the definition stuff that's on the very front page. And we're going to use the back page's last proof as our final example before you're on your own doing your own proofs, okay? Because we have to talk about a couple more progressions, which I mean by squares, okay? And yes, we should get the quiz stuff for you guys tomorrow then. Remind me again, hopefully. We'll get there. All right? Questions?
She was trying to tell us. She told
They need to.
What?